Hi, I'm Jim Little with LPKF Laser and Electronics. Welcome to our Getting Started program, where we'll cover all you need to know to start designing parts for laser welding assembly through production options for high volume assembly. Working with LPKF is easy because we're partnership based with clients who see this approach as a key success factor. As laser plastic welding experts, we know that working closely with you early in your program leads to better outcomes. We can head off problems early in the design phase before investments are made and validate designs before committing to full production. In this video, we'll cover the basics of laser plastic welding, including material selection, part design for manufacturability, risk management, prototyping, and the free resources and services available from LPKF to get your project started with confidence. We'll look at high-volume manufacturing options that reduce assembly risks for automotive, consumer electronics, and medical device companies. Why use laser welding? Well, if you're like most, you're looking for higher quality, lower cost, and faster ways to assemble sensitive electronic and sensor packages. So let's get started. Laser plastic welding is a mature, robust, and automatable solution for assembling plastic components. In this video, we're going to focus on the through transmission laser welding process, where natural laser transparent plastic parts are welded to a pigmented laser absorbing part, like those found in automotive, consumer electronics, and medical device packages, using the through transmission laser welding process. Through transmission laser welding uses a 980 nanometer diode laser coupled to a galvanometer, and the quasi-simultaneous welding method. In the quasi-simultaneous method, the laser repeatedly races around the contour, heating the entire welding area at once. 5 factors influence and allow control over the laser welding process. To achieve a successful weld, we need compatible materials, a transmissive upper part, an absorbing lower part, contact between the two parts, and the application of force. Most thermoplastics can be laser welded, including those with glass fill and additive packages like UV stabilizers or fire retardants that won't generally affect the welding process. There are 2 requirements for polymers to successfully weld. The first is chemical compatibility, and the second is similar melting points. Your material selection is based on the mechanical and environmental factors necessary to meet your product's requirements and the ability to laser weld the material. LPKF provides a material compatibility chart to aid in your selection of materials. The chart lists materials that have been successfully welded and relative bond strength. You can click the link below in the video description to download a copy of the material chart, and then work with your material supplier for their recommendations on materials to meet your specific requirements. Ask your material supplier for test plaques 1 or 2 millimeters thick for evaluation. We'll use those to get laser transmission measurements and perform test welds to get a first look at the process window. Test welds tell us whether it's easy to weld without burning or if it's difficult, subject to surface burning and/or a weak bond. Let's look at the basic design rules. Early designs used a lap joint design, which is a simple overlap of parts. Today, we favor the modern welding rib design because it allows for process monitoring and monitoring of the welding process, and therefore the quality of the weld that you can't get with a lap joint design. The welding rib is simply a narrowing of the wall within the top millimeter or 2 of the housing. When irradiated with the laser, the rib selection melts and collapses under the load of the clamping system, kind of like this. Well, maybe something more like this. The narrow, lower mass rib heats and melts under the clamping force in a controlled fashion. The welding machine monitors and displays the collapse rate and the distance traveled over time. If the process is in control, each part will have the same collapse rate and reach the targeted collapse distance at the same time. Process limits are established based on a DOE. A part whose welding profile falls outside of the control limits is flagged as a not okay part. We know that from the statistics gathered during the DOE, when a weld profile falls within the control limits, the quality criteria for that part are met. Your design needs to accommodate the expected melt flash from the collapse of the welding rib, and for space at the edge of the cover for the upper clamp to grip the cover and apply force. Plan on 1 millimeter for the outside edge clamp to grip the cover. Pretty straightforward, right? Now let's look at managing risk early in the design phase. Risks are in two areas and are easily managed and inexpensive to mitigate. The first is the part design that we've just covered. If you've accommodated for the melt flash and provided enough space for the edge clamp, you've covered the major risk factors for design. Additional risks may be identified, ranked, and managed by prototyping the assembly, creating proof of concept parts for design validation and testing. Through prototyping, we'll identify design and material weaknesses that can be addressed early in the program. In prototyping, we get our first cycle time estimates for production, and knowing the cycle time enables you to budget capital for the right production configuration. The second risk factor is material. A manufacturing engineer's dream is a wide and forgiving process window, and a lot of that falls on the polymer. The primary factor influencing what I call weldability is the laser transmission value of the cover. The cover can affect the amount of laser energy that reaches the absorbing part. And factors that influence laser transmission are the polymer crystallinity, glass fiber or talc content, and the thickness of the part. LPKF offers no-cost material testing and laser transmission measurements on your material using our TMG3 measuring device. And we'll do test welds of the material plaques to help you make informed decisions about materials early in the development process. The TMG measures laser transmission values at 980 nanometers, the welding wavelength. By checking transmission values against our material database, we can gauge the operating window and spot potential material problems before molding prototype parts, saving time and money. Materials that transmit more than 28% of laser energy seldom have a problem welding and are easily welded, creating robust hermetic bonds. Materials that transmit less than 28% of laser energy are more susceptible to surface burning of the cover before the parts are completely welded. Parts in this range can be problematic, but welding parameters can usually be found to produce a good weld. If the material has good laser transmission values, the next step is to perform welding trials on the test plaques provided by your material supplier. LPKF provides TMG laser measurements and test welds at no cost. Test welds are a quick way to explore the range of welding parameters to get a feel for how easy the material is to weld and identify any issues such as burning, incomplete mixing, and bond strength early in the process. We're rapidly moving along the development path. Material candidates selected? Check. TMG measurements completed? Check. Test welds done? Check. Elapsed time? 3 days. LPKF can turn around the initial material evaluations in 2 to 3 days, all at no cost to you. Let's move on to prototyping, where the plastic hits the road. LPKF offers tiered prototyping packages designed to meet your requirements for not a lot of money. A prototyping package from LPKF gives you everything that you need to get your prototypes parts done fast. For one low price, in addition to the free TMG measurements, test welds, and design reviews, we include prototype tooling, an applications engineer, the laser welder, and the welded parts that you need to validate your designs and test your parts. If you need more parts for testing, evaluations, or customer samples, just add on additional lab time at an attractive hourly rate, and we'll make as many parts as you need. During the material qualification and design reviews, we're already considering production scenarios and thinking about the best production solutions to meet your production volume and part quality requirements. LPKF is all about turnkey drop-in laser welding solutions that reduce manufacturing risks. When our development process is complete, you'll have design-validated parts and processes. The production recipe is loaded in the machine and it's ready to start running production quality parts on startup. When you're ready to kick off production planning, LPKF has the right production option for your assembly strategy. Whether it's integrated solutions that are part of an automated workflow or standalone welders with a dial table for flexibility and high throughput. Here's how to get started. Let LPKF worry about the welding so you don't have to. Are you ready? Step 1. Download our free design guidelines and material compatibility chart. The download link is right below this video. Be sure to click it. Step 2. Call or email us to get free materials and design guidance. Step 3, have your materials qualified for laser plastic welding by sending us a set of test plaques available from your material supplier, and we'll run transmission measurements and perform test welds at no cost to you. We'll send you back a lab report and your samples within 3 business days. Step 4, design review. Send us your CAD in step file format and we'll review the design and provide you with a report on any areas that need attention to help you reduce risks and assure the best part quality. Step 5, let's get prototyping. LPKF offers complete prototyping packages to meet your specific requirements. Prototype packages include design reviews, material qualification, prototype tooling, process development, and the welded parts you need to complete your initial testing, design validation, and customer samples. A Tier 1 package for small parts costs around $5,400 and can typically be completed in just 2 to 3 weeks. Now I've just outlined a low-risk, no-cost way for you to get your designs and materials checked, including a full report, in about 3 days, and a plan to get your prototype parts completed in 2 to 3 weeks. So what are you waiting for? Download your free design guidelines and material compatibility chart and get started. Thanks for watching. We look forward to working with you, and if you have any questions or need any additional information, please reach out to us. We're happy to help. Take care.